questions on the test that involve the rational root theorem. Now, with the rational root theorem, the first most important thing is to make sure to get your P's and Q's correct. So this is the first problem you're going to see on the test. P's and Q's. So remember that your Q is first. That's the most important part. So that's our Q, that's our P. Then I list out all my factors of P and Q. I always put P on top because then it's easy when I'm doing P over Q. So plus or minus 1, that's all the factors of 1. Q plus or minus 1, that's a factor of 5, and plus or minus 5 is a factor of 5. So then I do P divided by Q. Make sure you do all possibilities. So 1 over 1 is 1. So plus or minus 1 is a possible root, and plus or minus 1/5. Okay, so these are the possible rational zeros. So once again, if it crosses the x-axis and you have a zero that can be written as a fraction, it's one of these things. So we take our calculator. Now here's the next most important thing I really did notice on the test. It's really important that you make your window big enough so you can see far enough out, but you also make it small enough so you can see in really close. Because if not, it kind of looks like it only crosses the x-axis once, but it's really crossing it more than once. So I would always make sure on every single problem to make my window big as 20. So if I graph this, I go, y equals 5x cubed plus 11x squared, and then plus 7x plus 1, and I hit graph. So I can see it. My window right now is on -10 and 10, and I can see it pretty good. So I see it looks like it's crossing in, it looks like 3 places. So I'm going to get in there closer. My window I'm making to -5 and 5, -5 and 5. So I'm making my window small, and I'm seeing, yeah, it's definitely crossing in a couple places. I'm going to make my window even smaller so I can get in there really close so I don't mess up here. So I'm going to make my window like -3 and 3 and -3 and 3. So I'm just making my window really small, hit graph. Because now I can see, oh, it definitely crosses in many places. So if you were to graph this on your graphing calculator, it looks like this. So I got in there really tight. So I know it's crossing at here. Well, it bounces. It didn't come above. So it's bouncing right there, and then it's touching right there. So I'm going to do second trace, find the zeros. I'm going to do this first zero right here where it's bouncing on the x-axis because that is still touching the x-axis. So that's important to understand. Do you understand that your window needs to be really small? And if it bounces on the x-axis, that's going to be a 0. Okay, so I do left bound of that bouncing point, right bound of that bouncing point. I'm making sure I'm right of it, and my window is really small. I'm at -3 and 3 on my window. And I get x is equal to, thinking, negative, okay, so it says x is equal to -0.999, but that's really -1, right, if we rounded that? But we only round that up because that's what that would round to. Does that make sense? Well, if it was -9.8, we wouldn't round it to 1. Do you get that difference? Okay, so this is -1. Well, was that one of our possibilities? Yep, so x is equal to -1. Now I'm also going to do second trace because there's another place it's crossing, the 0. So where it bounces, that's only considered once touching. So left bound, I hit enter. I'm now doing this point right here. Right bound, I'm going up there, hitting enter. Oops, here we go. I hit enter, and I get, just a second, I messed up. Second trace, 0, hurry up. Here we go. Left bound, right bound. Enter, enter. So I get x is equal to -0.2. So I'm going to check and see if that was one of my fractions. So 1/5, is that the same thing? So I get out of my graph, I do 1 divided by 5. And what do you know? It's 0.2. So we know -1/5 is also a root. So you guys get what I'm doing there, right? Checking them all. So those are my 2 rational zeros. Now, interesting fact for you, I would give you bonus on a test, for example, if you were to go this far. You know how I said it bounced? Like, it didn't go, it bounced back down. So if I redrew this, it looks like this. Do you see how it bounces right there at -1? That's considered, it happens twice. So it's technically crossing the x-axis twice. It's -1 with a multiplicity of 2. So if you wrote this, I would give you the correct answers. If you said -1 with a multiplicity of 2, because it bounced, didn't go up and over. If it crossed up and back down, that wouldn't count. So with a multiplicity of 2, I'd give you bonus, which couldn't hurt. You're going to see one on the test that might bounce. Does that make sense, everybody?
So you'd say because it just crosses the x-axis. You say that.
Yeah, so it crosses the x-axis in 2 places. Right here, it's only like touching and bouncing back down. Do you see that? So like it's coming up, it's touching and going back down. But when it touches the x-axis, it's considered a 0. But since it doesn't actually go through the x-axis, it would be considered a multiplicity of 2 because it bounces back down. Does that make sense?
You'd have to put both those numbers, not just one.
But yeah, both of these are 0. So if you didn't put both, you would get it wrong. Okay. So make sure on the test you make your window really small and really big. Okay, we're all good with that? Like I went down clear to my window of -3 and 3 so I could see this in close. Because that's actually what we all messed up on. I didn't say that on the worksheet of this, and a lot of people missed rational roots because their windows were too big. Does that make sense? So get in there really tight and really big. So look at 2 different windows. Okay, next one. Oh, so there will be 2 problems like this. Don't miss them. Now, if you got -1, couldn't you have found the others by doing synthetic division, and you would have got for sure 1/5? Or does that make sense? Like, that's the long way of doing it though, right? Because this question just says rational zeros, but I'm just saying. If you wanted to be sure that there were no other rational zeros or that you were going to miss one, you could have used one of those to do synthetic division. But with this one, you don't have to. Is everybody good with that? Questions? Okay. Those are not multiple choice. Okay. The next thing on the test is going to be this. It says find a polynomial with the given zeros, and it's going to be multiple choice. Now, I went through and I've made some common errors, so you got to be really careful. So, find the polynomial with these given zeros. Remember, zeros are x values, so we have x is equal to -2, x is equal to -7, and x is equal to 1. Are there any conjugate roots I need to add in here? Nope. So, make sure you don't add any extra roots. Does everybody understand how come why there's not? Because there's not any imaginary roots and there's not any irrational. So then we bring them over. So we have x plus 2 is equal to 0. Bring them over correctly. Like, don't just say x minus 7. You've got to bring the 7 over correctly. So we have x plus 7 is equal to 0. Subtract 1. So I have x minus 1 is equal to 0. So now, since they're all equal to 0, I can pull them together and multiply them. Now, take my suggestion. If you ever have 3 or 4 things, multiply 2 of them together, combine like terms, then multiply the others together. So I'm going to just randomly choose these 2 here and focus on them. X squared. Be very careful on the test. You're going to see one this easy, but it's just easy to make errors, and it's a tragedy when you miss the easy ones due to errors. X squared plus 2x plus 2x and then plus 4. And then, oh, that's a 7, not a 2. I can't read my own writing. Okay, so x squared plus 7x plus 2x plus 4. Combine like terms first.
It's 14.
14, that's not a 2. Why the heck? I think that little thing's messing me up. Okay, so plus 14, combine like terms. X squared plus 9x plus 14. Combine like terms first. Does everybody get that? Then you'll put parentheses around that, multiplying that x minus 1. So distribute very carefully here. X cubed plus 9x squared, and then plus 14x. And then I'm going to distribute -1, so negative x squared, negative 9x, and minus 14. Combining like terms, I cross them out as I go so I don't miss anything here. So I have an x cubed. 9x squared minus 1x squared is positive 8x squared. Positive 14x minus 9x, 5. plus 5x. It's kind of early, guys. Can't add and subtract today. And then minus 14. Yeah, that's right. Okay. So like I said, on the test, it's multiple choice. And so just make sure you've done it all correctly. Like recheck your work and everything, because I have made some of the common errors. Yeah. Yeah, absolutely. Oh, yes. Yes, you absolutely can. And so, good point. There were 3 zeros, right? Right?
Yeah.
So it better be degree 3 in the end, or you've done something wrong. Good question. Okay, good point. Okay, so with this one, we have find the polynomial with the given zeros. Now, zeros are x values. X is equal to 5. X is equal to 2i. Now, remember, if you have an imaginary root, its conjugate is also a root. So not only 2i is a root, I have to know I need to add in negative 2i. Then from there, bring things over. Subtract 5. You got to bring them over correctly. We have x minus 5 is equal to 0. Subtract 2i. Subtract 2i. So I have x minus 2i is equal to 0. Add 2i. Add 2i. So x plus 2i is equal to 0. Because they're all equal to 0, we can now multiply them together. Take my suggestion. Always multiply your conjugates together first. So we have the negative 2i, the positive 2i. We've got to multiply those together first, just because it's going to be a lot prettier. So x squared minus or plus 2ix minus 2ix. Careful here. Negative 2i's times positive 2i's is negative 4i squared. Then from there, combine like terms. X squared and minus 4i squared. Now, I squared is equal to negative 1. So what we really have here is x squared minus 4 times by, instead of I squared, times by negative 1. Negative 4 times negative 1 is positive 4. Don't add them. Do not add them. It's multiplication. So negative 4 times negative 1 is positive 4. So x squared plus 4. So everybody good with that? And now we'll multiply in our x minus 5. X cubed plus 4x minus 5x squared minus 20. I'm going to change and put it in standard form. X cubed minus 5x squared plus 4x minus 20. And once again, it's degree 3, and it better be, because we have 3 zeros. One, two, three.
So if it's just an I, like, will it ever just be an I right there?
Yeah, so x, it could. X equals I, then x also equals negative I, and you'll just bring it over and multiply it through. Yeah, it could be. It'll be the same as like a 2i though, because that's just like a 1i, right? It's the same process. Okay. So there'll be 2 problems like that. Do not do conjugate roots if you can't have a conjugate root. None of these have conjugate roots. I's have conjugate roots. So it's a change of sign in between. Okay. Factor and solve. That's all I'm going to say. Factor and then solve. Now you have to choose that you're factoring by grouping. So look up here. Don't say, oh, what multiplies to be a times c. It's not quadratic. That's a quadratic thing. What we do is say, okay, factor and solve. Well, it's not quadratic, so what other method can I use? Do I have 4 terms? Yes, if there's not 4 terms, you cannot factor by grouping. But there's 4 terms, so I'm going to try factoring by grouping. I group these first 2, group the second 2, including that sign right there. So then I focus on each group, and I make sure I factor out the greatest common factor. Okay? If it's not the greatest common factor, you're not going to get it right. So they both have a 3 in common, 9 and 24, right? And they both have an x squared. So 3x squared is what I'm pulling out. What you pull out is what you divided out, but you've got to write it. So then I go through and divide each thing by what I pulled out. 24 divided by 3 is 8. X cubed divided by x squared is x. Negative 9 divided by 3 is negative 3. And then x squared divided by x squared is 1. Negative 3 times 1 is just negative 3. Is everybody good with that? Then from here, You cannot say there's nothing in common. There's no such thing as not factoring something out. You either have to or it didn't factor by grouping. But we can always factor out a 1, right? Now there's nothing more in common, so I'm going to factor out a positive 1. Divide each thing by 1. So left is 8x minus 3. Check your safe haven. If it's not exactly the same, including the sign, you've done something wrong. So then we factor out our safe, because that's the same, I can factor it out. So I pull out 8x minus 3, and left is 3x squared plus 1. Okay, from there, if you get that part right, you get half the points. Now you have to solve it. Well, what's the point of factoring? Like, why the heck do we learn factoring? It's so we can solve our x values. Now, the whole point of factoring is so we can set each factor equal to 0 and solve. So I'm going to set 8x minus 3 equal to 0. And I'm going to set 3x squared plus 1 equal to 0. Set each factor equal to 0 and solve. So this one's linear, so it's easy. I'm going to add 3. You're going to have fractions. So you have 8x is equal to 3. Divide by 8. So x is equal to 3/8. You're going to have a fraction on this one on the test. There's only one problem like this, and it's pretty easy. So if you miss this one, it would be a waste of points. I mean, it's somewhat easy. It does take some thinking. Any questions up to here? Now this next piece, it is, okay, so we're solving this piece. Now it's quadratic, so you can either solve by the quadratic formula. If it solves by factoring, you can factor it if it's factorable. Or you can use the quadratic formula. Did I already say that? Okay, or if you're missing your middle value bx, then you can just, that's the easiest kind, you can just isolate x squared and then take the square root. So I'm going to subtract 1. So we have 3x squared is equal to -1. First, this is the important thing, guys. First, you have to divide by 3. So I have x squared is equal to -1/3. Is everybody okay so far? Now you are okay to take the square root of both sides because x squared is isolated. Square root of both sides. Root cancel out with power. X is equal to plus and minus, and I'm going to split that up. So on top I have the square root of -1. On bottom I have the square root of 3. Now I will not give you the full points if you don't simplify it all the way because we have to be at that level. Okay, so I'm going to just focus on the top. What's the square root of -1? I, guys. It's I. So we have I on top, and on bottom we have the square root of 3. Now, if you stop here, you get almost full points, but not. Because we can't have a root in the bottom. Does that make sense? Roots in the bottom, we have to rationalize. So, because we have a square root of 3 in the bottom, I'm going to multiply the bottom and the top by the square root of 3. So on top I have I square roots of 3, and on bottom I have the square root of 9, which is 3. So if you did this, you get full points. Now look, we have 1, 2, 3 answers. Okay, we have 3 answers. I checked, was it cubic? Yes. Okay, we've done this correctly then. So the biggest thing is, first we factor by grouping. Then once you have your factors, set them equal to 0 and solve. Now there are actually 2 of these ones on the test. One of them is going to be missing a bx, so you'll be able to solve as such. You might have to rationalize the denominator, just like this problem. But the other one, you're going to come out with a quadratic, well, let's see. Oh. Okay. Okay, just making sure I'm in the right spot. Is everybody good with this one? Okay. Okay, good. Okay, next one. It will simply say, this is the last part of the front page of your test, it'll say find all the zeros. So we have 5x to the 4th minus 41x squared minus 36. So first of all, this is 4th degree, so we know we're going to have 4 zeros. It says find all the zeros, and then I even gave you a hint. I was feeling pretty nice last night, and it says find the whole number of roots, then get it to be quadratic, and use the quadratic formula or other method to find remaining roots. So that's pretty obvious what to do, right? I'm basically telling you what to do on the test. So we find any whole number roots. So this is where you get your calculator. Graph it. Finding all the zeros. So 5x to the 4th. Because we don't have 4 terms here, right? So we can't factor by grouping. So 5x to the 4th minus 41. X squared minus 36. I hit graph. And my window is not big enough. So I'm going to change it because I still have my window at -3 and 3. So it's looking pretty, like I can't even see what's going on. So I'm going to change it back to the standard viewing window of -10 and 10. And I'm going to hit graph and see if that helps. Okay, so I see on my graphing calculator, it looks like this. It's crossing in 2 places. One right there, one right there. So I'm going to pray that they're whole number roots. So I do second trace, find the zeros, and I'm going to find each of those. So left bound, to find this root, left of it would be up here, right? Left of it, so I have to make sure I scroll left. If you can't see where your little dot is, you have to use the bottom of your calculator to see like where you're at. So it says I'm at like -4. So I'm going to just make sure I'm left of it. So I'm at like, I'm randomly choosing, okay, I'm at -6. That's probably left of it. I mean, it is left of it. So I hit enter. Right bound, I scroll right. I can't see where my little dot is, but I know I need to be right of it, and it says I'm at -2 right now. So that's probably, I mean, that's right of it, -2, because that's at least at -1, 2, 3, it looks like, at least. But I can't assume it's at -3. You have to trace it. Okay, I hit enter again, So I get x is equal to -3. So then I do the same thing over on the other side, and I get x is equal to 3. Is everybody comfortable with that? So guess what? There's 2 of our answers. X is equal to -3, x is equal to 3. Now we have to find 2 more, and it's to the 4th degree. So I'm going to use synthetic division to get this down to be quadratic. So I'm going to have to do synthetic division once, it'll be cubic, twice, it'll be quadratic. Now here's the biggest thing, guys. When you're doing synthetic division, this is so important. I hope you're listening. If you're missing, and you are going to be missing things on your test, there's a missing cube, right? 5x to the 4th, and then there's a 0x cubed missing, right? And there's a 0x missing. You can't forget that, or else you're going to get it wrong. Is everybody good with what I'm saying here? So I'm setting up synthetic division. I'm randomly going to choose 3 first. I put it in a box. And I put my coefficients, 5, 0, -41, and 0, and -36. You have to put in your zeros, and I'm telling you the one on the test is missing some things. So we drop that down, add straight down, right? Is everybody good?
Yeah.
Okay. So 15 times 3, 45. So we get 3, 4, 20, add straight down. No, wait, where did I mess up? Because that's got, oh, yeah, 12. Okay, I was going to say, because that has to come out, the remainder better come out to be 0. So we're doing 4 times 3, which is 12. Add straight down, we get 12. There we go. 12 times 3 is positive 36. Add straight down, we get 0. Your remainder better be 0, or you've done something wrong. So either you forgot your zeros in here, or you've just done synthetic division wrong. Like, see how I knew because I multiplied this and put a 20, and I'm like, my remainder didn't come out as 0. So where did I mess up here? Okay, so our remainder is 0. So what we have here is that's our remainder, that's our constant, that's our x squared, x cubed. X cubed, we still want to make it, we want to make it quadratic. So we're going to do synthetic division again. You've got to use the other root. So now I'm going to use -3, coefficients 5, 15, 4, and 12. Your remainder is now gone. You don't have a remainder, so you don't need to write in that. Drop that down, we get -15, add straight down 0. 0 times -3 is 0, add straight down 4. 4 times -3 is -12, add straight down 0. So our remainder is 0, we've done this correctly. So if this is our remainder, this is our constant. If that's our constant, that's our x. If that's our x, that's our x squared. So we have 5x squared, and then plus 4. Now that's our quadratic. That's not our answer though, but we know how to solve that. So we'll set it equal to 0, solve for x piece by piece. Because we're missing the middle value, which I'm telling you right now on the test, one of them you're going to be missing bx in the middle, so it's easy, right? The other one, you're going to have all three things, so you're going to have to use the quadratic formula. Okay, so I'm telling you, there will be one of each on the test, yeah.
But how do we know which one to start?
What do you mean?
Like,
Oh, actually, good question. You can start with either or.
you can?
Yes. So it would have been the same thing if I would have started with -3 and then done 3 the next time. We would have come out with the same answer. Good question. So I subtract 4. So I have 5x squared equal to -4. This is a really good one because, like I said, if you don't simplify your answers, I'm not going to give you full points. Divide by 5 first. So we have x squared is equal to -4 fifths. And now because x squared is isolated, I can now take the square root. And then I have x is equal to plus or minus the square root of -4 over the square root of 5. So what I have is x is equal to plus or minus the square root of -4 is 2i, right?
Yeah.
And then it's over the square root of 5. That's not a simplified answer because you have a radical in the bottom. Rationalize it. And I'm telling you, this looks very much like the one on the test. We have plus or minus 2i square roots of 5 over the square root of 25, which is 5. There's 2 answers. And then we also had x is equal to 3, x is equal to -3. We have 4 answers here, which makes sense due to the fact that it started out to be 4th degree.
Right then.
Any questions on that? Okay, so I don't think I'm doing another example like that. I don't think we need to anyways. Nope, I'm not. But I'm telling you, once again, if you were to do synthetic division, I'm telling you on one of them, you're going to get something like this. 5x squared plus 3x plus 1, for example. So solving that quadratic, you can't just subtract 1, divide by x, right? There's no magic way of solving this except for the quadratic formula or solving by factoring if it's factorable. And the one on the test is not factorable. So you better know your quadratic formula correctly, doing it correctly. Right, so your a value is 5, your b value is 3, your c value is 1. X equals -b plus or minus the square root. Yeah, okay. But you just got to type it in correctly and simplify it correctly. So everybody, do I need to go through the quadratic formula on this one?
How do we know, like, something is going to work for it?
Synthetic division will always work if you have a whole number root.
Okay.
Does that make sense? Yeah. Okay. Next thing on the test you're going to see is name the polynomial by degree and by number of terms. So let's go ahead and do these. You always go look up the highest degree, and then there's degree 3, and then there's 2 terms, right? So that would be considered a cubic binomial. These are multiple choice on the test, so just know your stuff and you should get them right. Is everybody good with that? Cubic binomial. Next one, this is degree technically 1, right? Degree 1. So, and there's 2 terms. So it's linear and it's also a binomial. So there's 2 terms. This one is a quadratic because it's degree 2. Quadratic. And then there's 2 terms, so it's a binomial. This one is degree 4, so that's quartic. 4 quarts in a gallon, quartic. And then it's 1 term, which is monomial. So there's monomial, binomial, trinomial, polynomial of 4 terms. Polynomial of 5 terms, polynomial of 6 terms. Is everybody good with what I'm saying? Okay, then there's constant. So a constant would be like 5. There's no x, right? Constant. There is degree, there's linear, that's degree 1. Quadratic is degree 2. Degree 3 is cubic. Degree 4 is quartic. Degree 5 is quintic. If you have 5 babies, you have quints. And then after that, it's just 6th degree polynomial. 7th degree polynomial. Is everybody good? You'll want to know those names, because these would be so dumb to miss. All right, next few. Simplify. That's all I'm going to say is simplify. So you have to decide, am I adding, subtracting, multiplying? Look at these two polynomials. Are we multiplying? No, so do not distribute. Distributing's a multiplication property. We are not distributing. We're literally combining like terms. It's just addition, so you're just combining like terms. 2x to the fourth plus 3x to the fourth is 5x to the fourth. Negative 2x plus 7x is positive 5x. Do not multiply if you're not multiplying. Okay, hardest one, subtraction. We have this polynomial. Subtract this polynomial. Once again, do not multiply.
We just combine like terms.
We combine like terms, but with subtraction, we do have to be more careful because there's a negative 1 in here, right? So it is negative 1 times all that stuff. So I distribute it through. So we have negative 2x cubed. Positive 2x, right?
Negative 5.
Negative 5. Now, everybody, this is where Garrett kind of confuses himself because he puts in parentheses around these. But since we've distributed the negative 1 through, we don't need parentheses anymore, right? Does that make sense? So don't start to throw people off. This front thing, we didn't need to do anything to that, so we still have 3x cubed minus 7x. And then from there, we're combining like terms. 3x cubed minus 2x cubed is 1x cubed. Negative 7x's plus 2x's is negative 5x's. Be so careful. And then negative 5. Do not multiply if you're subtracting or adding. You will do some sort of multiplication with subtraction because we've got to distribute our negative through. Okay, questions? Okay, also in simplify, something like this. These ones are being multiplied. They're right next to each other, so we are multiplying. So we're going to double distribute, combine like terms. So careful on these. 2a times 7a squared is 14a cubed. 2a times negative 3a, negative 6a squared. These just have a lot of room for error because there's a lot of multiplying of exponents and stuff, and you've got to, when you multiply the same base, you add your exponents. You just got to be really careful. 2a times negative 2 is negative 4a. Negative 5 times 7a squared is negative 35a squared. And then we're going to keep going with this. So negative 5 times negative 3 is positive 15a's. Negative 5 times negative 2 is positive 10. I know some of you are going to get, at this point in the test, a little bit zoned out, and you're going to not pay very close attention and go through this kind of glazed over, and you're going to miss it. So you've got to go through it very particularly, because there's a lot of negatives, okay? So 14a cubes, no other a cubes. Negative 6a squared minus 35. Negative 41a squared. Negative 4a plus 5a's is positive 11a's.
That's 15.
Right, sorry, did I say 5a's?
Oh.
Yeah.
Sorry. Positive 15a's minus 4a's is positive 11a's. And then plus 10.
See that.
Questions? Yeah.
Have we done multiplying and dividing like fractions yet?
You mean polynomials? Nope, that's about where we're about. Okay guys, so next thing on the test. Find the zeros, find the max and min, then graph and state the end behavior in words. So find the zeros. Just use your calculator for this one. So type it in. Negative x cubed plus 2x squared minus 3. Hit graph. I see it looks like it's crossing in one place. I do second trace, find the zeros. I'm going to do left bound, which is up there, right bound, down there, enter, enter. So it's crossing the x-axis at negative 1. So I write x is equal to negative 1. So I know it's crossing at negative 1, right? So I'm going to graph this very accurately. So now it says find the max and min. So max and min. I am going to do it in my calculator. Second trace. I'm going to do minimum first. So the minimum is the lowest point. So you have to be left of it, hit enter, be right of it, hit enter. If you can't see a max and min, get your window smaller. Does that make sense? Make your window small. Okay. So I get a minimum of negative, and your mins are going to come out as decimals. Negative 1.15, and then our y value is at negative 3. And our max, second trace, I'm finding the maximum, left of it, make sure you're left of it, right of it. Enter, enter, and I get x is equal to 1.33, comma, negative 1.8. So now I can graph those two things. I have a maximum at over 1.33 up down negative 1.8. So over 1.33 down 1.8, so that's right about there. And then I have a minimum at negative 1.15 down 3. So negative 1.5 down 1, 2, 3, down 3. So now you can draw your graph. Just use your calculator. It looks like it's coming down. From here I won't be picky. So it comes down, hits that minimum, goes back up. Wait, what the heck? Oh. Shouldn't cross the x-axis anywhere other than 1. Did I say 1? Negative 1.33? So let's see. I went over 1.3 down 1.8. That is good. Then this one I went negative 1.15. Let me redo that minimum. Because that's not making sense here. Let me redo that minimum. What am I missing here? Second trace. Find the minimum. Left bound. I might have just wrote it down now. Right bound. Now I got something different. So let me see what I'm doing wrong here. And I did now. So this actually was negative 1.5, and then it says e to the negative 6. So that means times 10 to the negative 6, right? So that's a really small number, right? The times 10 makes it a really small number. Is everybody good with that? So that's actually less than 1. So that's why my graph wasn't making sense. Okay, so that's less than 1. And then, I mean, it's less than negative, greater than negative 1. It's really small, and then down 3. There, that makes more sense. Okay. Does everybody see how you just got to look really carefully at that? It does say e to the negative k. So then my graph is coming in through here. It should only cross the x-axis right there at negative 1. Look at your graph. So it's crossing at negative 1, comes down, hits that point, comes back up and down. So try to graph it as accurate as possible. Does that make sense? Okay. So then end behavior is up and down on this one. Up and down. Yes. You would write times 10 to the negative 6. Because if you don't write it, it's not the right thing. That's why my graph wasn't making sense while I was sitting here looking at it forever. Because without that, it didn't make sense. Because then it was over here, and I knew my graph didn't come through, bounce, and come back down. Does that make sense? So I was like, something's weird, because it was crossing my x-axis and then coming over here, and that didn't make sense. Does that make sense? Okay. Okay, questions on that one? Sorry about that. Hopefully the one on the test is a little bit more straightforward. And it is. I just threw this example on the board. Okay, here we go. Okay, so divide this using longer synthetic division. I'm giving you the choice. I always choose synthetic division because I think it's easier. So with this one, we have this divided by this. So if you're going to do synthetic division, you have to say, okay, so r plus 3 is the factor. So we set it equal to 0 and solve. So we have r is equal to negative 3. Because with synthetic division, you use the root. So I set up my box, negative 3. I have a 3, a 17, a 20, and a negative 20. I'm not missing any factors in between, so I didn't need to put any zeros. Is everybody good with what I'm doing here? Would anyone prefer me to do it with long division? I mean, is anyone in here going to do long division over synthetic?
Heck no.
Okay, so we have a negative 9. So 17 minus 9 is 8. 8 times negative 3 is negative 24. So it's negative 4. Multiply back up, right? Are we all following me? And then negative 20 plus 12, negative 8. Okay, so this is our remainder. This is our constant. This is our x. This is our x squared. So our answer will be 3x squared plus 8x minus 4 with a remainder of negative 8. We divided the two polynomials. That quick. Now it should make sense, guys, because it was degree 3 and now it's degree 2. We only did division once, so it'll only take it down 1 degree. So if you come out with something weird there, you know you've done something wrong. If you came out with a degree 4, you'd say, uh-oh. If you came out with degree 1, you'd say, uh-oh. Does that make sense, everybody? Okay. Okay, so now the next thing it's going to say is, so you'll choose to do that one. There's only one like that on the test. The next thing says, state if the given binomial is a factor of the polynomial. And then I even tell you basically how to do it. Show using the remainder theorem and synthetic division. To get full points, you have to show me both. So we know, yeah, we've got to hurry. So we know that we would, oh wow, this is super long. We would do synthetic division, get a remainder, right?
Yeah.
Then we would plug in oh, no, wait. Yeah, then we would plug in, because we would have -9, right? That's what we would do synthetic division with. Is everybody good with that? Then we would plug in -9 into here, and you better get the same thing as your answer as your remainder. Does that make sense? Yes.
Just solve for the second part, and that'd be -9.
Right, and that's what you use in your box, and that's what you plug in into your function. Does that make sense? So that's what I want you to do on this one, is check both. Just show -9 cubed plus 11 times -9, and then you'll go through and you'll have a remainder. So like, whatever your remainder came out to be, let's say your remainder came out to be 23. Then when you plug it in, it better be 23. Does that make sense? If not, something went wrong here. Or, the answer could be, so if it is, here's the thing guys, if that's a root, won't our remainder be 0? Is everybody listening? That's important. If that's truly a root factor, then this root is a 0. So our remainder will be 0. So if your remainder is 0, you'd say yes. If your remainder was 23, you'd say no, right? Does that make sense, everybody? That's a root, then your remainder will be 0.
Wait, so you don't have to do all that?
No, you do. Because I say use the remainder theorem and synthetic division to prove that it truly is a root or is not. So if it was 23, the answer would be no, right? Then you're showing using this that that was the remainder. Okay, simplify and state the excluded values. You guys, with simplifying this, you've got to factor the top, factor the bottom first. So we factor this. We pull out a 2. Left is 2k plus 1. Everybody's following me. I have to go through these fast. We have 15 minutes. Divide now, because this is being multiplied, you can divide them out, right?
Yeah.
Before you divide them out, though, you have to state any excluded values. Is the bottom doesn't have any variables, right? So there's no potential 0. So there's nothing. So divide both of those by 2, this becomes a 5. So our answer is 2k plus 1 over 5. There was no excluded values in this one. But what if it was this way? We would factor the top, which is done, factor the bottom. So the bottom we factor out 2, left was 2k plus 1. Before we divide anything out, state the excluded values. Isn't this the potential problem area? Yeah. So set it equal to 0 and solve, and that's where it can't be equal to. So k cannot equal -1/2. Can everybody solve that in their head really quick?
Yeah.
Okay, so now you can divide them out. This became a 5, this became a 1. So our final answer is 5 over 2k plus 1, where k does not equal -1/2. Okay, questions on that? Okay, next few. Simplify. Factor the top, factor the bottom. We have n plus 2 over 5 times n plus 2. Before you divide anything out, state the excluded values. So n cannot equal -2, right? Divide those out. This becomes 1 over 1, so 1/5. As long as n does not equal -2.
How'd you get rid of the 10?
We pulled out a 5, left was
so
n plus 2.
-2 you got from that.
Setting that piece equal to 0. If this had a variable, we'd set that equal to 0 as well. Okay, next one. Factor the top, factor the bottom. So this factors to be k plus minus, let's see. Well, multiplies to be 18. That can't be right. Nothing multiplies to be 18 and adds up to be 18. Why? I must have wrote that one down wrong. So let's do this. What multiplies to be 18 and adds up to be negative?
Wouldn't it be easy to do -17?
Yeah, -17. I wanted this one to factor, so I'm like trying to think of how. Yeah, so let's just do that. I guess maybe I'll just skip this one.
Yes.
Back to the top, back to the bottom, right?
Yeah.
Divide out things, but before you divide them out, you state your excluded values, right? Okay. Okay, next one, simplify. We're adding these, so you have to get a common denominator. You can't magically make this 5. That's one of your most common mistakes. You have to multiply by the full thing. So I multiply by k plus 5, k plus 5. I multiply by k minus 1, k minus 1. Look at your bottoms. Are they the same now? Okay, so now we will distribute that through. So we're going to have 5k plus 25 plus, distribute that positive 5 through. It's positive 5, right? And you'll have plus 5k minus 5. And that's all over the common denominator of k plus 5 times k minus 1. You don't need to multiply out the bottom. Leave it factored. So on top, we combine like terms. 5k plus 5k is 10k. And then positive 25 minus 5 plus 20. Right, everybody?
Yeah.
And that's over k plus 5 over k plus k minus 1. Then you'll check to see if it simplifies. So I can pull out a 10. Left is k plus 2 on top. And on bottom we have k plus 5 and k minus 1. Nothing divided out, right? We don't have to state the excluded values with adding and subtracting.
Holy crap.
So what's my common denominator here? This one needs a 4. This one needs an x minus 1. Right?
Yeah.
And then we do that to the top and bottom. Be careful though with this one. Here's the most missed thing on the test. This is negative, all of that, right? Times that. So really we're doing negative 4x and negative 3.
Would you distribute it though?
So I distributed the negative through to both of these.
Yeah.
And then I'm going to multiply it in.
Oh,
Does that make sense?
see.
Are you
So
sure?
that'd be negative 4x squared.
So yeah. So then, just with subtraction, you have to subtract all of that. So there's a couple different ways you could have done this. You could have not distributed the negative and then distributed it very last. Is everybody good with that?
Yeah.
I'm feeling bad we didn't get through this half. But I guess you'll have to be okay.
Oh, that's that one solved.
Back to the top. So it's multiplication, right?
Yeah.
Back to the top, back to the bottom, back to the top, back to the bottom. Then you divide out exact factors only. And then multiply straight across.
Wait, how can you factor out 9 minus 9? And minus 9.
You can't. So that piece is factored. Does that make sense? But in this one, we can factor out n squared, right?
Yeah.
And then left is n minus 9, right?
Yeah.
Does that make sense? And then guys, with division, flip the second and multiply, right? Back to the top, back to the bottom. Okay.